If you've been on social media in the last week or so, your feed has probably been full of photos like this. Gorgeous images of the northern lights from across Europe and North America. But why? Why does our sky sometimes do this? Why does it put on these spectacular light shows? My name's Thomas Runtoul. I'm a PhD student in astrophysics at Cardiff University, and in this video we're going to first talk about what an aurora is, then why they're concentrated near our north and south poles, before rounding out the video with why this week's northern lights were quite so spectacular. The aurora are undeniably gorgeous, great light shows that fill the sky with ribbons of green and red, and they're a direct consequence of our nearest star, the sun. You see, the sun doesn't just emit light, it sends us more than that. The Earth is immersed in the solar wind, a stream of charged particles, mostly electrons, protons, and alpha particles, that get cast out in all directions from the sun, reaching us at around 400 kilometers per second. These particles come to us from the solar corona, a thin atmosphere around the sun, where temperatures reach around 1 million Kelvin. Because these particles are so incredibly hot, the sun's gravity can barely hold on to them, and many get swept out in what is the solar wind, being streamed across the solar system. The aurora we see here on Earth, and that we see on other planets like Jupiter and Saturn, are a result of these charged solar wind particles interacting with the individual molecules in the upper atmosphere. When they interact with the nitrogen and oxygen that make up our upper atmosphere, one of two things will happen. The most common is that an electron in a nitrogen or oxygen atom will be excited by this collision. This is the quantum mechanics term for saying the electron gains energy and orbits in a higher energy level. In more extreme cases, that electron will be ripped out of its atom, ionizing it. But this just tells us how electrons are removed or excited. Where does the light come from? The energy comes from the electron releasing that energy, whether it's been excited or ionized. If it's been excited, it will drop back down to the energy level it started in, releasing some energy as a photon of light. If it's been excited, it will be recaptured, again losing energy and releasing that as light. The color of light that you see depends on the energy that's been lost. It's set at a very specific frequency. In the case of our atmosphere, when an electron in an oxygen atom de-excites, it's going to release either a green photon or an orange-red photon, depending on what energy level it was excited to. For the nitrogen atoms, if it's been ionized, it's going to release a sort of blue-purple light, whereas if it's just been excited, you're going to get a more reddish light. This explains why we get aurora, why we have these light shows in the sky. What it doesn't explain is why they're concentrated at our poles. Why do we have the northern and southern lights? This happens because the solar wind doesn't just interact with our atmosphere, it also interacts with our magnetic field. The Earth's magnetic field is awesome. It's constantly protecting our atmosphere from being stripped away by the solar wind the way that Mars's atmosphere was. It's also responsible for the aurora being concentrated at our poles. I mentioned before that the particles in the solar wind are charged. This is important. If they weren't, they wouldn't interact with the magnetic field. But they are, which means the magnetic field can exert a force on them. This force being known as the Lorentz force, after Dutch physicist Hendrik Lorentz, who mathematically derived this force in 1895. The Lorentz force that a particle feels is proportional to the electric field and to the cross product of the particle's velocity with the magnetic field. What this means is the particles are going to feel a pushing force perpendicular to both their velocity and the magnetic field. This has the strange effect of coupling that particle to the magnetic field, forcing it to rotate around the magnetic field lines, and in the case of the solar wind, be pushed towards the magnetic pole, either north or south. This force is responsible for the charged particles of the solar wind making their way to the poles of the Earth and lighting up the sky with magnificent aurora. But while this explains why we have the northern and southern lights, this doesn't answer the question I started off this video with, which is why this week's northern lights were so spectacular and why they were seen so far south. It's a good question because normally the northern lights, or the aurora borealis, are only seen at the very northern latitudes, normally visible in the likes of Canada, Iceland, northern Scotland, and Scandinavia. But this week, they were seen as far south as Florida and Cyprus. So what gives? What gives is the sun. It has an 11-year cycle between the minimum of its activity and the maximum of its activity. And we're nearing that maximum now. At the maximum, you see more star spots, more solar flares, and more of what happened this week. Coronal mass ejections. A coronal mass ejection is basically the sun belching a load of material out into space. A lot of pressure and tension builds up in its magnetic field, and when there's too much, it breaks out, sending out massive amounts of plasma from the sun. If the Earth happens to be in the path of one of these coronal mass ejections, the magnetic field will divert the material towards our poles. But if there's too much, you will see it at much lower latitudes than normal. That's what happened this week. There's been a series of coronal mass ejections that have impacted the Earth's magnetosphere, sending charged particles far more than normal towards our poles. That's what was responsible for the outstanding aurora that we've seen all over social media this week. Unfortunately, I moved to Cardiff 8 months ago, a city with quite a lot of light pollution. So, yeah, I missed this one. Of course it happened like 8 months after I moved from Scotland. Fingers crossed for the next one, I guess. I really hope you enjoyed this video. I knew when I saw all the aurora pictures on social media this week, I had to make a video about them. If you have photos yourself, please do tag me in them. I'd love to see them. Also, apologies if I look a bit warm and uncomfortable. It's like 28 degrees in my office right now, and I've had to turn off the fan to not ruin the audio. If you're looking for something else to watch, there's some recommended viewing on screen now. Make sure you subscribe and hit the bell icon to be notified about future videos about our crazy, wonderful universe. And all that's left for me to say now is thank you very much for watching. I will see you in the next one.